Hello everyone. So today we'll be talking about Kubeflow pipeline building. So here I'll be using the iris classifier model training and prediction steps. So these are the different steps or topics I'll be covering. So starting from Python function needed to train and predict the model. So here I'll be training the model and writing some prediction steps. And then what we'll be doing, so converting these functions to the Kubeflow components. So that will be our second step. And then we'll be initializing the Kubeflow pipeline. So just simple initialization. I will show you how to do that one. And then define the pipeline function and put together all above component which we created in second steps. Okay, so we'll be seeing this. And then we'll also mounting one volume for components output storage, because every component will be generating some temporary output which we need to store, and then of course we'll be reading it for further processing purposes. And then at sixth step we'll be compiling the pipeline and generating the YAML. So basically from here onwards there are two ways you can directly use this YAML and upload in the Kubeflow pipeline section. I'll be showing you everything. Or also what you can do, you can generate the experiments and run through the code itself. Okay, so we'll be seeing that part as well. And then so this seven steps what I explained, like using the code part, how to create the run and experiment. And then one more thing I observed basically, so if you're running multiple times your pipeline, so what happens, like so whatever the components or steps have been run in previous pipeline execution, so their output is taken from the cache. So what happens, you're not able to see the output exactly. So that's why there is a need sometime to disable the cache. So I will be showing that part also. Okay. So basically, so this is how our pipeline will look at the end. So I just took the snippet and kept it here for a display purpose. So like here you see the volume and then different machine learning steps. So okay. So this is whole thing we are going to create. So before I just start, guys, so I'm assuming you have already installed the Kubeflow pipeline component at least. So in my system, I have not installed the complete Kubeflow. So whatever needed, like a pipeline experiment, so like pipeline SDK I have installed. So that is the mainly used one. And yeah, so if you have not installed, then let me know if you need some help on that side. So I'll can create a video on installation purpose. But yeah. But right now, I'll be just going through how to create a Kubeflow pipeline, assuming you already have the setup done in your system. Okay, so let me start. So here, like I'm importing some of the libraries or packages. So here, like KFP is nothing but the Kubeflow pipeline SDK. So that's where I'm importing it. And then from KFP.component, I'm importing the components. And then request to some request for HTTP request, and then DSL. So this will be used for pipeline initialization. Okay. So one more thing, guys. Here I'm going to show you like what Kubeflow pipeline version I'm using. So because in new upgrade, so sometimes some keywords gets changed or something new is added, so old one is not working. So for that purposes, it's very important to know like what version we are working on. So as of now, we are working on like 1.8.18. So this is the Kubeflow pipeline version I'm using. So I would suggest you also install the same one and then you can proceed. But mostly it should work with other version also. Okay. But still you should be a little careful. Like sometimes it doesn't work. Okay. So that's the basically the warning or whatever you can say. But moving ahead, so the very first step of what we create in the model training, like prepare data. We start with preparing the data. Okay. So that's so one more thing, guys. Here I'm not explaining model buildings, basically how to train the model and hyper tune that one, right? So that's not the scope. So that's where I am including very basic model training step, and the main focus will be on Kubeflow pipeline explanation. Okay, so please keep that in mind. So here the very first function, prepare data. So here I'm importing the pandas as PD, and this is some just printing purpose. Just it will look how it will look in the output basically. And then pd.read CSV, here I'm just reading the iris data CSV file, and then just one step df.drop na. Okay, I'm not doing any other pre-processing steps. As I told you already, I'm not going here. The scope is not to explain you the model building phases. Here we will be focusing on Kubeflow pipeline building. Okay, so So that's why the next step. So here I'm just df.to CSV using this. I'm just saving this CSV data. Okay. So just I have given a new name like final df.csv just to make sure, like, okay, just to tell you basically. So here you write all your pre-processing steps and then you create your final data and then save that one. Okay. And what is this data slash? So here basically in further steps, I will be creating persistent volume, and what will the path for that? That is slash data. Okay, so that's where whatever you want to save, you just save using data slash. Okay, so that thing. Of course, you can take this data part as a variable also, and then you can use that variable. So that's also fine. Okay, so here, so this is, and one more thing, guys, let me explain. So in every function, so guys, here every function will be converted to separate component. Okay, and every component, for every component, a separate container will be initialized. Okay, so that's where in every container you need to have all the dependencies present. Right, so that's where here it is mandate or it is required to mention every dependency inside the function itself. Okay, so that's where in this function I'm needing only pandas. So I'm just importing pandas as PD and doing all other things. Okay, and similarly, next function like train test split. So in this function again, separate component and separate container will be initialized. So every dependencies are needed. So here again, you need to import everything needed for the successful completion of this function. We need pandas, we need numpy, we need scikit-learn dot model selection train test split, right? And then here these are the some steps like some basic Python. So wherever any specific related to Kubeflow component that I will explain, other thing Python related I will skip. I'm assuming this thing you already know because you are in Kubeflow pipeline building, so it means you already know model training and a bit of Python, right? So again, I'm reading the see here. So whatever CSV I have saved in previous step, so I'm just reading that one, the process data basically, right? So here you can save it to any bucket. It could be S3 bucket, it could be GS bucket, any bucket, right? Any cloud storage. And here also you can read from any other cloud storage your data, right? So that's the thing. So here I'm just reading this process data and then defining the target column and then doing X and Y. X will contain all the predictors data and Y will contain all the target, sorry, only one target variable, right? So that's how I'm just doing this, and then X train, X test, Y train, Y test. So normal train test split. So normal machine learning thing, right? And then again, so this is the train test thing we got, and then I will be saving this to persistent volume. So using numpy array np.save, you can save it. Okay, and then here I'm simply printing. So when I will be executing this function as part of Kubeflow component, then you will see this output. Okay, so after execution, I will be just showing you. Okay, so let me execute this part. So this is just the function definition. So this will not show any output as of now. Okay, once we call it, then it will show. And third function is like training basic classifier. So here again, I'm importing the dependencies, whatever is needed, because these will be executed in separate container. And then X train and Y train, I'm just loading them and then training the logistic regression classifier, right? And then importing pickle so that I can just dump this model.pickle file. Okay, so it will be again saved inside data folder. Okay, persistent volume. So let me execute this also. And then the fourth one is like predict on test data. So what here I'm doing, so here again, I just import all the dependencies again and again. I'm reminding because this is a very specific to Kubeflow. And then with open, so whatever model I have created in previous step, I'm just loading again, guys. So this here saving and loading part you can do from any cloud bucket, it will be supported. Okay, and here I'm loading the logistic regression model, and then numpy.load, I'm loading the X test data, and then doing the prediction using the trained model in above step, and then again saving the ypred. So the ypred will be nothing but the predicted classes on the target data, and here you will see the output. Okay, so this is how you need to write the component. So this is the function basically I will be converting into the component later. Okay, again predict probabilities on test data. So same way here everything will be same, just this function predict proba. So this will get changed. So here in above step we have dot predict, so it will give you the predicted classes, and this will give you the predicted probabilities of each class. Okay, similar way, and then get matrix. So here I want to just see some matrix printed, right? So here these are the libraries I will be needing again for separate container, and then these are the normal machine learning work, and then I'm just printing the matrix. Okay, some matrix. So till here, I'm assuming everybody knows. Okay, you are familiar with. So from here onwards, so Kubeflow component creation work is start. Okay, so let me execute these steps. Okay, so yes, okay. So let me write this thing also for your reference purpose. So like Kubeflow pipeline. Okay, so this is start from here. Yeah. So now whatever function I have created above, so for every function, I'm going to create a component. So how you can do the component creation? So using KFP that you have already imported at the very beginning, kfp.components.create component from function. Okay, so this is the function you need to call. And then inside that, what argument or parameter you need to pass? The function for which you want to create the Kubeflow component. So using func, so this is the this is how you need to give the parameter. Okay, so the first parameter is like func, and you need to give some value to that. So the value is nothing but the function name, and then base image. So you need to pass the base image. So like as I said, every component will be containerized. Okay, so for every component, there will be separate container created, separate pod, and then separate container. So that's where we need to have all the base image. So like here, we'll be needing a Python 3.7. And on top of that, what packages you need to run that? So for this, we need pandas and numpy only. Okay, if you need anything else, you can pass using commas. Okay, so here, just mention these things. So these are the only needed. Okay, and then you just run this, and similarly I can create the component for second function. Second, what was the trend test split? Here also I will be needing 3.7, but here I need scikit-learn as well. Okay, so I am passing scikit-learn with the corresponding version, like what version I'm going to use. Okay, so let me do that also. And then similarly this third function, fourth function, fifth function. Okay, and then the last one, that is the get matrix. So all, so this everything is same, right, till here. So the component creation. So here starting from ninth line, so this I'm creating the Kubeflow components, right? Still I have not created the pipeline. I'm just defined the component. So the next step, like here, you need to define the pipeline. Okay, so how you can do? Using dsl.pipeline, you can initialize the pipeline, and how, what you need to pass the name of the pipeline and description, little description, so that you get to know what it is doing basically. Okay, and then define a pipeline function. You can name anything here. So I'm giving iris classifier pipeline. Okay, and data path. So here you can pass the data path basically. Is what is that one? So here you see, like everywhere I'm using this data, right? So if you are passing from there, then of course you can initialize, you can normally a string and that variable, and then you can use that variable here for saving purpose. Okay, so for that purpose it is. Okay, so you do just by yourself. If you are getting any problem, just let me know by the comment. I will just explain. Okay, so here, so data path str. So I'm just defining this function definition. Okay, I'm not calling here. And in next step, I'm going to call. So that's where I'll show you like this data path. Okay, and then here, this is what I am defining the persistent volume. So here, how you can do dsl.volume operation, and you can define the name of the volume, resource name, and how much size you want to give, 1 GB, and mode like volume mode read write operation. Okay, so that's what that will be the mode for this. Okay, this is how you can create the volume, and then you need to bind all the component you created in above steps. So how you can do that? So create step prepare data. So that was the first component, right? You created here. So create step prepare data. These are the first step, right? So that's where you can do this, and then you can attach a volume with that one. Okay, I'm attaching the volume. Okay, and what will be the volume path? So that you need to give using data path. Okay, so that is slash data. Okay, and volume operation dot volume. This is nothing but this thing. Okay, so similarly, you can create all other steps. So here also create step training test split, and then I'm adding the volume to that one. And then one more important thing, guys. Here I want to execute this component only once this component is executed. So like in sequence, because I want to consume the data of this output of this in this step, right? So that's what I'm writing dot after prepare data task. This is the first task. Okay. Once this gets completed, then only start this one. Similarly, I'm training like next step is classifier training. So create a step training basic classifier, and here add volume, and again I'm adding the volume. This is the same thing, and then after this second step, right? So similarly, you can see we have created this 5 or 6 steps. Okay, in this complete machine learning training and prediction thing. Okay, so these components I have created and then binded this inside this pipeline. Okay, and now next thing, whatever I have commented basically, so I will uncomment this. So what is this basically? So this is needed to disable the cache. So P0D means 0 day. So there won't be any cache. If you don't write this for each step, then if you have already ran this pipeline, then it will fetch the output from previous run. Okay, but I want to show you the fresh run. Okay, so that's where I have just disabled the cache. But if you are running the first time, then this thing you don't need. But if you are running the second time, then of course you need to have this. Otherwise, it will fetch the from cache and it will not show anything. Okay, so let me, yeah, previous steps I have ran. So let me execute this also. Okay, so now I have executed this. Now in this step, what I am doing, I'm just compiling the pipeline, whatever I have created here. So this is, I have defined the pipeline. Okay, now I'm compiling. So here kfp.compiler.compile, then it will compile, and then here inside you need to pass the pipeline function name, and then package path. So whatever file name.yaml. Okay, in this it will output everything. So basically the moment I run this, okay, it will generate a pipeline. So here, so I have opened the Jupyter notebook. So I have ran this code already. Okay, so this pipeline, if you see, this YAML file is created on an hour ago. Okay, so let me refresh this also. This is an hour ago. Okay, but the moment I run this code, okay, so it will show immediately generated one. Okay, because I've given the same name. Or let me give you another name. Okay, one. Then run it. So it ran and it has saved the pipeline in the same location where my notebook exists. So here I go. So see, this immediately generated, right? And if you see here, it will contain the whole code of your pipeline. It will have all the steps like get matrix, every step it will have. Okay, and volume path, everything it will have. So you can directly use this pipeline and upload it in your Kubeflow here. So if you come here and pipeline section, you upload it. So I'll show you this after, once I just show you the code part. Okay, so you can upload it here and it will work directly. Okay, but let me go back to the code part. Okay, so here it has, so basically the use of this, you just generate this YAML file and you can share within your team. Okay, so that's the advantage of this. Okay. And now the next thing, like if you want to run this or create the experiment via code, so how you can do this? So for that, you need to create a Kubeflow client, Kubeflow pipeline client. So because I am running this in my local host, so what I can do kfp.client, it will initialize the client. Okay, but suppose your Kubeflow is installed in some of the server, maybe if you're working in your office or some other project. So for that, and there are multiple namespaces. Okay, so for me, I have installed it locally. Okay, on my Kubernetes. So for that, I have used Minikube. Okay, for cluster creation, and on top of that, I have created this Kubeflow, install this Kubeflow pipeline. Okay, but if it is running on some server, okay, so for that you need to authenticate this as well. Okay, so that's where you need to pass the session cookie like this. You can right click and inspect, and then you can get the session cookie. And if you're facing some problem, just let me know via comment. You can pass the host name, that is where your Kubeflow is installed. So like this, you get this host, just copy that one. Okay, and then you need to pass the namespace. If you are using if you have multiple namespace, like one could be project namespace, one could be user namespace, like that, multiple namespaces could be there, right? So you need to pass which namespace you are working on. And then once you have that information, then you create a Kubeflow client. So kfp.client, you pass the host like this, cookie information like this, and pass this namespace information. Okay, but this you don't need if you are working on local. So you just do this. Okay, So I have tested this in both the places. It works if you have in server or local. Okay, so let's go with because I'm running this in my local host. Okay, so let's go with that one. So let me execute this. The moment I execute, so Kubeflow client is created, and now in the next step I can create the experiment, and on top of that we can create a run. So here you can pass the data path. So as I was showing here in Kubeflow pipeline is expecting one data path as a string, and that I'm using here, right? So that's where you can do define a argument slash data import date time. So this I'll be using mainly to so that multiple time you run this code. So experiment name will be created with new name. Okay, so here pipeline function, whatever pipeline you have created above, so this function you need to pass basically here. Okay, this name, and then create experiment. So any name you give here, and plus I'm suffixing with date time, so that every time I run, I get a new name. Okay, normal Python thing, right? And run name, so Python pipeline function run. So any name you can provide. Okay, so I just want to prefix it with pipeline name. Okay, namespace, of course, I will be not needing because I have only one namespace. If you have multiple namespace, then you need to provide the namespace information as well. Okay, so arguments will be data path only, and then you compile this, and then what you need to do, client dot create run from pipeline function. This is the function you need to pass, and inside that you need to pass the pipeline function. So this one I have initialized here, then experiment name you created here, and then run name again you created here. Okay, and then arguments you created here. Okay, this one. And here, see guys, here I'm not passing the namespace because I am running it locally and I have only one namespace. But I have already tested, if you have multiple namespaces, then you need to pass the namespace information as well. So like this here, I commented this part, right? Same way. So you can pass the namespace information as well. And also, if you have your base images placed somewhere in some repository, okay, and to fetch that you need some secret information, okay, to authenticate that. So for that you can define some pipeline configuration thing as well. Okay, so you just define from Kubernetes import client as get client, okay, pipeline configuration, so like this. So here whatever your Kubernetes client is, okay, and then pipeline config dot set image pull secret. Okay, so you can define where your secret is, you pass your namespace information, and if you have some secret, okay, and then image pullback policy, if not person, like this you can define, and then you can pass that as an argument here. Okay, but I'm not using that one, but you trust me, I have tested this also and it works perfectly fine. Okay, if you are running in some server, you can test that there also. But in locally, so how you can do basically, so like this. Okay, so and now if let me check, I've run this. Okay, so now if I run this, so immediately you see like here as output, experiment got created and run got created. Okay, so let me run this. So now you see, so this date, forget about this, I just printed here, so that's where it is showing here. Okay, and now experiment got created and run got created. Okay, so now if I click this, okay, it should directly redirect me to that one. Okay, but the thing is, my notebook is running in another port, and Kubeflow pipeline is running in 8080. Okay, so like let me go 8080. Okay, and now it will open that one. Okay, so now refresh. Okay, so it is taking some time because I'm obviously running from in my local machine. Okay, so it is heavily loaded. So what we can do, we can come to Kubeflow here, and from here let it open. So here we can see, okay, the very first one, okay, so which we have created recently just now. Okay, we ran. So let me go to that URL. Anyone can come first. Okay, so just a minute. Yeah, this came. Okay, so just the where we went, just change the URL. Okay, so tvol, so it has created the volume, so volume got created, and now you can see, like, okay, immediately next step is also executed here, prepare data one. So like inside prepare data component, and data CSV is saved to this. So if you just go back here, and now you just start observing your function. So what happens in the first one, what we did in the first one, what we did, like we just printed inside prepare data component, and then again we were printing this, right? So that's where, like, here in the this prepare data, so these two things are outputted, right? Now next thing, train test split. So here what we did basically, again, let me show you first what we are printing inside train test split component, and then we are printing this x train, x test, y train, y test, right? So if you go here, okay, so then here x train, so this is your x train data, okay, in which you will be training the model, and then this is x test data, okay, and then here we have y train data, and this is y test data, okay, so like this. So whatever you have printed here, like x train, x test, y train, y test, okay. And next step is like it is training the basic classifier. So now if you go here, so okay, so it is still inside this, okay, let it exit. It takes some time because of course it is my local machine, so it is not that fast. So let it run. So meanwhile I can just, okay, so let me not refresh this again, and that it might impact this as well. So let's wait. Yeah, so you see like this step got executed, and backend it has also executed this training basic classifier step, okay. So now here you see like if I expand this, so inside training basic classifier component, and then logistic regression classifier is trained on iris data and saved to PV location, this, okay. So same thing we have printed here. So this training basic classifier inside training basic classifier component and logistic, these two outputs are shown. And now in predict on test data, so now here we are loading the test data basically, where, so np.load, here we are loading the test data. And one more thing guys, so in some of the numpy versions, so for security related things, so they have by default made allow pickle is equal to false, okay. So that's where if you don't write this, so you might face some problem. If you are facing some problem with that, like allow pickle is false, then you just pass this as an argument, allow pickle is equal to true here in numpy.load, then it will work, okay. I faced this, and then I thought, okay, why to downgrade the NumPy version? Okay, let's use this thing. So same thing, now I come here. So here you saw this output training basic classifier. And now in predict on test data. Okay, so predict on test data. So these are the predicted classes basically. So this is the same output I have printed here. If you go here, right? And then predict probabilities on test data. So here again, I'm loading the model, okay, which we have saved in previous steps, loading the x test data, and then using the function predict probabilities. So this is normal machine learning function, right? So here it will show me the all the probability values. So in this, so this is the predict on test data. So next step, it is still executing. So just a minute. So it is bit slow basically. Okay. So if I just don't refresh, otherwise, okay, we can refresh it. Okay. Just a minute. So it is hanging because of my local machine. See, if you come here in Docker, so it is consuming this 7 GB RAM space. So let me again refresh it. Just a minute. So maybe I can open it from here. If I go to run, okay, so this is the latest one which we are using. So we can also open from there also. Okay, so this is the same thing, same one. So we were there training basic classifier, and here we see this output, and then predict on test data, okay, and then predict probabilities on probabilities on test data. So these are the probabilities values, okay. So this is the same run basically, guys. Okay, so 043, this is the same run, okay, and here also you're seeing 043, this one, okay, and here also you see, so it's the same run basically, okay. So now here, now get metrics, so it is still working on this get metrics part. Okay. So if your machine is fast, then of course it will run quickly in your machine. Okay. So so meanwhile it is printing get metrics, I am also going to explain like how to upload the pipeline, and then see that create the experiment and run from the UI itself, user interface, this one, right? So maybe I can come back and again go there. So yeah, because it is not refreshing in my system because machine is a bit slow. So now you see how it output look like. So now inside get matrix, you see, so this is the same thing we have printed. If you just come to get matrix function, what we are doing, so we are printing inside get matrix component, and then we are printing this confusion matrix, basically classification report, and not the confusion matrix, basically the classification report, and then accuracy, precision, recall, entropy. Okay, so now if you come here, same thing. This is the classification report, which has all these details, and then we are printing this accuracy, precision, recall. Okay, and here these corresponding metrics for different classes. Okay, so that's how, guys, you can build a different build Kubeflow pipeline. Okay, and here you see, like, I have written here like dot after, like this after. Okay, so that's why they are running sequentially. So this is also one important thing to run, how to run it sequentially. Okay, now another thing, what is pending. So this I have shown you by creating the pipeline from the code section. Now what you can do, you can also upload the pipeline using this section. Okay, you come here in the pipeline and go to upload pipeline, and here you define the pipeline section. Okay, so manual pipeline, okay, anything. Okay, and description pipeline testing from UI, and then we have upload pipeline, and then you just select your pipe file. So basically I just show you where it is. So once you executed this step, this one, right, so wherever your Jupyter notebook, it will be saved in that location here. So we just shown like 8 minutes ago we created this one. Okay, so we'll upload the same pipeline. Just okay, let me take it there itself. Okay, now here in upload file, what you can do, choose file, and here this one, right, one. Okay, so iris classifier pipeline one, this one we recently created, right? So let me open this, and it will be uploaded. And now here you can also paste your code source here, but we have file, we'll use that one, and click create. It will create your pipeline. Yeah. Okay, so same graph has been created. This is known as directly cyclic graph. And then once you are here, so after this you can create an experiment. You can give some experiment, like experiment from UI. Okay, uploaded pipeline UI pipeline. And then you can give some description next, and then manual pipeline, it will automatically select, because from there only we are creating. And then description, it will take the run name by default. Okay, and then one, and then you can pass the data. Okay, whatever data variable you are using inside that one, and then click start. Then it will start this immediately, and now you can go inside that one, and it is working. Okay, it is running. It will take some time because we have disabled the cache, and it will work. So that's how we can create the Kubeflow pipeline, basically, guys. Okay, so this is all about this video, guys. So one more thing I want to tell you. So if you are installing complete Kubeflow, okay, with all the component, then even here you get Jupyter notebook section, like notebook server, Kitev, that is hyperparameter tuning, case serving, a lot of things. I mean, many things you get here. Okay, but because of my local system capacity, I have only installed the pipeline SDK, because that is only needed thing. Okay, I can run this Jupyter notebook from separate, right? So that's where I've installed this one, but working will be same, so no need to worry. So if you are opening a notebook from this Kubeflow component itself, okay, then what will happen? So whatever link we are generating here, this one, okay, this will directly point to that location only. Okay, and here if you see in the bottom port number 4x8, so here you don't need to change that one, because you have opened Jupyter notebook from Kubeflow component itself, because my Jupyter notebook is hosted separately. So that's why the moment I click there, it will not open, but the moment I change the port, okay, because my Kubeflow pipelines are running in 8080, then it will open that one. Okay, so see, it is opening that one. Of course it is a bit slow, but it will open, same thing. Okay, so that's the difference, basically, guys. And you will see all other components, and run, you will find all the different runs here. So okay, and if you go to experiments, you will find different experiments. A bit slow, but yeah, you will find it here. So that's all about this Kubeflow pipeline explanation, guys. If you face any problem, any doubt, just let me know via the comment, and I will be happy to explain it there. And one more thing here, I have not explained how to install Kubeflow using some Minikube thing in local. If you want to know that part also, then let me know. I will just create one video on Kubeflow installation on your local machine. Okay, so that's all, guys. So yeah. So, and also one more thing, if you like my video, then please don't forget to subscribe my channel. So that's how you can motivate me. And also please share within the machine learning community. So that's all. Thank you. Bye-bye.